Hello there, my name is Gregory Carlson, and we're in the calculus building, and we're trying to figure out if Nero stopped at that stop sign for an infinitesimal amount of time. For that one frame, did he stop at that stop sign? And it's not looking good for him, because as we take his average speed, as he gets closer and closer and closer to the stop sign, on times before 3, it looks like he's approaching a speed of 6. And I did times on the other side of 3, and it looks like we're approaching a speed from 6 in the other direction. So let's test one more. Let's just see what his average speed was from 3 to 3.00001. So let's see what his average speed was when he was really close to that stop sign. So we plug it in. It'll be 3.00001 squared. So let's grab our calculator. We have 3.4 zeros. Let's square that number. I get 9.00006000001 divided by, oh, and that's going to be minus 3 squared, which is minus 9, over 3.01 minus 3. And in fact, look, I accidentally did it backwards at the end of that last video, so I apologize for that. I hope you will correct this. That should have been 3.01 minus 3. Anyway, so this is going to equal, all 9 minus all of that is going to be 0.000060000, 4 zeros and then a 1. Yep. Over 0.00001. Okay, let's see what that is equal to. So we'll take off the 9 and divide it by 0.00001. And look at that. Look at what his speed seems to be approaching as we take the average rate of change coming from the other side now. So you know how limits work. Seems to me we've got a limit going on here. Our left-hand limit seems to be approaching 6, and our right-hand limit seems to be approaching 6. And so the two police officers call up Nero and they say, we're sorry, but if we take this value right here, f of x minus f of c, in this case we were using t, but I'll use x right here, divided by x minus c. This is the average rate of change formula. But what we're going to do is we're going to take the limit as x approaches c. And sorry, Buster, but if we put in a 3 right here, it's pretty obvious that the limit that these two things are approaching is equal to 6. This limit is going to equal 6. Your speed at that instantaneous moment in time was not 0. Life is not made up of a series of frames that are all at speed of 0. Your instantaneous speed at that moment in time was equal to 6. And so this idea right here is an extremely, extremely important idea. In fact, it has a special name. The limit as x approaches c of f of x minus f of c divided by x minus c is equal to something called the derivative. In fact, it's equal to the derivative at that point c. This is a very, very powerful and important idea. What it means is that even for a curved function like x squared, we're going to be able to figure out the instantaneous rate of change at that value. In fact, here's what Nero's curve looked like. It looked like this. And here was the 3rd second where the stop sign was. And what we were doing was we were taking the average rate of change. We were taking the average rate of change between these 2 points. And we saw that, the speed was coming up and the speed was coming down from the other direction. And they converged to this tangent line right here that had a slope equal to 6. And so we were taking, there are some great graphics that I'll show you that show that we were taking the average rate of change, the average rate of change, the average rate of change, And we were letting x get closer and closer and closer to c, and we found that if we take the limit as we approach that magic value, you're going to be an instantaneous rate of change at that moment only of 6. This process of finding the tangent curve, the instantaneous rate of change right there, that's called the derivative. And we're going to look at some more formal definitions of it in the next video. I hope you're excited. If you like this video, please like and subscribe. Let's talk about the derivative. See you next.